The GageMetrics setup is where you do your programming. It's also where we're going to go in right now and we're going to associate our probes. First thing we need to do is tell this program what probes we're dealing with, and each pencil probe or block gauge has a designated address, and so we need to address each probe and associate it. Over here, this is where your program is being built, or identified, you might say. Over here is where the hardware that we're going to use from our inputs. All of our inputs are coming from Solartron. So I'm going to click on the Orbit Network, and it brings me into a screen. Each one of these tabs is where I get to list what we're using. And I'm using a transducer. It's 14-bit. So transducer number 2. And there's an address in there already. I'm going to go ahead and associate transducer number 3 in a minute. I'm going to click on Scan Inputs. I'm going to click on number 3. And I'm going to click on Notify. Now I'm going to come to the gauge and I'm going to pull on number 3. I'm just going to make that transducer move. Of course, it'd be much easier if these weren't sunken down in. If you notice, it found the address that is specific to that transducer. Each transducer has an identity that's different than any other. Now we're finishing the association of these probes. You can see, again, we've got transducer number 2 through transducer number 15. We only have 14 and 15 left to associate, so I'll show you how to do them again. Go to Scan Inputs. We're going to click on 14, which is, you can see it's blank. It needs to know what kind of probe and its identification. We're going to click on Notify. It's looking for a probe to move, so I'm going to the gauge and I'm going to make probe number 14 move. You notice that it found its type, its device type. It also found its identification. Again, that's the identification specific to just that probe. Last one is probe 15. Click on Notify. Again, it's looking to see something move, that probe. That probe moved and you see it found it. When you're done, that's all our probes. I simply say OK. That's all your probes. Each one of these has a name. This is a name that you get to change if you'd like. Within this program, we have the ability of creating many features. This tree over here, if you go to the very last block, which is what I described as your third blade, when you select that, you gain 2 tabs up above. One of the tabs is Part Inspection Sequence. That's your program. When you click on that, that shows each line item that you get to write specific. Within this, we have what's called an event. Under an event is where you get to make your calculations. So, for instance, I have M2, which I would describe as measurement number 2, is equal to D2. And D2, if you recall, was the description of probe number 2 when we associated. So if I want to edit that and I want to look and see what it means, it says that the probe number D2, from when we associated, we named that probe D2. We're saying that D2 is equal to M2. That's the measurement number 2. And over here on the left, we get to choose whatever we want to do with that probe. We can add, we can subtract, we can add one probe to another probe. There's many, many functions over here, way too many to list or to discuss. At this given time, though, within this program, we simply have one probe equal to a measurement. When you come back out, you get to look at, basically we have probe number 2 through probe number 15. You can add another measurement very simply by going to your event, clicking on the measurement button up there, and creating a name, calling it whatever you'd like. I could call that ER4 if I wanted to. Wouldn't really matter. I come over to select what probe I want to use. For instance, probe D4. If I want to come over on the side here and select a slot, I can select D4 minus D12. 12, and that will give me that slot width. This is prompting me for some questions of what you'd like it to do. I mean, some specific things. You simply answer any way that makes sense for your application. I want to use the selected, what I actually chose. Or I can click Create a New One. The reason it's doing that is because we already used probe D4 once before and D12. And it's asking, are you sure you want to use those measurements again? Yes, I do. And so now I have created, if I go in and I edit this and I look, I can see that I have a new feature. However, I'm still using raw probe value. Sometimes you may not want to do that. You may want to use the M4 and the M12, which is the measurement from them, to create a feature. It depends upon your application. Okay, it's important for us to know how to save changes. There's a load or backup application. When you click on this, you have the option of backing up or loading an application. And you have a checkbox here that you can exclude the data that you've saved. All this means is that you're not backing up all of your saved data, because you should be saving your data to a network drive or to another drive anyways. So we'll simply back up the application, and it's going to write a time-specific and date-specific backup file. It zips it when it's done. This keeps your file size smaller. So I'm going to simply say Save. But before I do that, you're going to notice where it's going. You get to choose, if you'd like, where you want this saved off. Simply click Save, and it writes your backup. If you want to go ahead and load a different backup, for instance, you want to run a different part program, click on Load Application, and you get to choose whatever backup file you want to load in and start running. This time we're not going to do that. We're going to stay within the one we've got. Next thing we're going to do, we're going to get ready to set master. So we need to bring the transducers in location that we needed to retract for loading and unloading purposes. And then finally we're going to move the transducers, but before we do that we're going to go back to the screen and show you what function key or what menu it takes to get to your set mastering. The screen that we're defaulted at right now is for gauging. You notice there's an LT, that's gray or red. What that could mean is either a linear travel fault in a minus condition or an over travel position. It means that the probes are not activated in a readable location. In this case, the gauge isn't turned on. We're going to go ahead and go to the menu button, and under menu button we have gauging or mastering. Right now what we need to do is click on mastering or hit the F2 function key. We're going to click mastering. Because we've never mastered this before, we need to teach an ideal setup. We need to tell this gauge where the probe should be from now on. This ensures that if you ever have a probe that is loose in the gauge or damaged, it should show up in a mastering fault, because your mastering should be very, very accurate compared to yesterday's mastering or next week's mastering. Nothing should vary a large degree unless something mechanically is moved. That's what this is for. We're going to come down here to Options. Under Options, you'll see Teach Ideal Setup. We want to click on Teach Ideal Setup. When we do that, we're now going to actuate our transducer valve, and that's going to turn all the probes on and make the probes come out and meet the set master. Once it's done that, we're going to click Read, and it says Do Not Move the Master. Right now it just set all of them probes, and it says from now on where you are, I'm calling that 0. Click OK, and it automatically brings us back to a gauging screen. Now that says NMV, standing for no movement. It's looking for these probes to move, and they have not moved yet. They're still contacting since the set mastering. I'm going to deactivate and reactivate, and this should measure exactly 0 because we have the set master in place. So at this time we're ready to gauge a part. It's important to get the transducers set the right length away from the part. You can do that by either putting them in the middle of their travel, or if you prefer, having a bit more retract. The place we're going to do that is we're going to go into Menu. We're going to go to F3, or Set Up Transducers. By clicking on that, we can actuate our gauge. And when the transducers reach the set master, they're going to give us a location of where they're at in their travel. Now I've got these all set, and it's simply as easy as loosening the set screw that holds the transducer in its hole and moving it back and forth while you wait for this to fall in the green area. Of course, I got this set for mostly retract, and this is over travel. But these are 10 millimeter transducers, so you've got nearly 3 millimeters of over travel, more than adequate for this particular part. When this is done, now we can go out to our gauging screen. This time we're going to lower the part down in the gauge. We've got 6 points, 4 of them in the root, and 2 of them out near the tip. We're being careful because this casting is quite heavy. Once it's lowered in, we're just going to ensure that it's against its nest. Actuate the clamp, actuate the slide, and actuate the transducers. That time we'll be able to see the values on the screen. What you see on the screen currently is measuring that exact casting. You notice you'll see green, red, and yellow. Green is obviously good and within part limits. Yellow is a limit, would be crowding outside of your upper or lower specification limit. And then red is out of tolerance, whether it be in a negative or a positive value. The upper and lower spec limits are something that you can set, and we'll go to that screen in a minute. All right, we're going to go back into GageMetrics setup, which is where the programming happens. Right, now that we're in the setup, we have over here on the right many options. Documents. You can pull documents in if you'd like to, specific documents that you want your operator to reference during a measurement application. This could be a picture. This could be multiple different things. Whatever document you would like that operator to see, this will show up visible on the screen and prompt them to either read it or at least notice it. Configure text exports one that you're going to definitely want to pay attention to because it is where your data is being saved. When you save that data or you read, it captures your data and it saves it to a log file somewhere. You can set this up to save to a CSV file, or you can set it up so it goes out to a simple comma delimited format. CSV is probably your most easiest and least amount of operator intervention. You can write parts to an export folder, export data in English units, or leave it unchecked and it'll automatically go out in metrics. Export as deviation from nominal, or you can uncheck that and it'll just simply export what the value is. You got an upload interval. By clicking on upload interval, you can save every 30 minutes or every 1 part. We checked both 30 minutes and 1 part. That allows the operator, as soon as every part is measured, you click read, it captures the data specific to that part. We're just going to click done. You notice down here on destination though, this is where you get to set its path. So you can come over here and click and set the location of where you want this data saved. Master sequences, this is where our, when we load our steel master in, we assign ultimately a similar program as what we do for the part. We're actually loading an event that says mean master for D2, 3, 4, and so on for every probe. Mean master means exactly a nominal reading, or perfect you might say. We can do min mastering, max mastering, or mean mastering.